What happens when a star, in spectacular fashion, dies? The answer begins here. Stars, the celestial engines that light up the universe, forging the very elements we're made of. But how are they born? And how do they meet their end? Let's take a journey through the life cycle of stars, from their fiery beginnings to their ultimate fate, where one path leads to a quiet fade and the other to a spectacular explosion that echoes across the cosmos. It all begins in a vast nebula, a colossal cloud of gas and dust drifting silently through the darkness of space. These clouds are the stellar nurseries of the universe, where the seeds of stars are sown. Over millions of years, gravity slowly pulls these particles together, causing dense pockets to form. As the gas collapses inward, the pressure rises and the core grows hotter and hotter, eventually reaching temperatures of millions of degrees. Deep within this swirling chaos, a new light is preparing to shine. For billions of years, an average star, like our Sun, remains steady, burning hydrogen at its core in a delicate balance of pressure and gravity. Through the process of nuclear fusion, hydrogen atoms combine to form helium, releasing an immense amount of energy. This fusion not only powers the star's warmth and brilliance, but also pushes outward against gravity, keeping the star stable. For much of its life, this balance allows the star to shine brightly, radiating light and energy into the vastness of space. But eventually, the star's supply of hydrogen runs low. Without enough fuel to maintain its delicate balance, the core, now mostly helium, contracts under gravity, growing hotter and denser. In response, the outer layers dramatically expand. The star swells to an enormous size, hundreds of times larger than before. It becomes a red giant, its outer surface cooler, giving off a deep reddish glow, yet still radiating immense energy. During this stage, the star undergoes intense internal changes. Helium begins to fuse into heavier elements like carbon and oxygen. Its appearance is calm, but inside, it's turbulent and unstable, an aging giant nearing its final act. In its final breath, the dying star sheds glowing gases, forming a delicate shell that shimmers like a cosmic bloom. This phenomenon is called a planetary nebula, a beautiful, haunting reminder of the star's former glory. At the center remains a white dwarf, hot, dense, and dim, slowly fading over billions of years, a silent relic of a once vibrant star. Now, let's look at the fate of a much larger star, one far beyond the size of our Sun. These massive stars begin their lives much like an average star, but with a crucial difference. They burn through their fuel at a much faster rate, causing them to live shorter but more intense lives. As it nears the end of its life, the massive star expands far beyond the size of our Sun, becoming a super-red giant. The outer layers grow so large that they stretch across vast regions of space. At the core, heavier elements like helium, carbon, and oxygen begin to fuse, creating even more energy, but also putting extreme pressure on the star's core. Eventually, the core becomes too unstable to hold up under its own gravity. The core collapses inward, triggering a cataclysmic explosion, known as a supernova. In a flash of unimaginable brilliance, the star detonates in a supernova, releasing an immense amount of energy, outshining entire galaxies for a brief moment. What remains after the explosion is a supernova remnant, a vast, expanding cloud of gas and stellar debris rushing outward into space at incredible speeds. One such remnant is the Crab Nebula, glowing debris from a massive star's final explosion. What remains depends on the star's mass. Some collapse into ultra-dense neutron stars. A few spin rapidly, becoming pulsars, cosmic lighthouses flashing beams of energy across space. But if the collapsing core is massive enough, even light cannot escape. A black hole is born, an object so powerful that it bends space and time itself. Its gravity is unstoppable, pulling in anything that dares to stray too close, even light itself. But even in death, stars play a pivotal role in the creation of new worlds. The remains of these cosmic giants, scattered far and wide, seed the universe with the building blocks for future stars, planets, and even life itself. What seems like the end is often just the beginning of something new. Every atom in your body, every trace of matter around you, was once part of a star. These ancient explosive deaths create the elements that form planets, life, and even ourselves. The universe, in a never-ending cycle, recycles itself, endlessly weaving new stories from the ashes of the old and continuing the grand cosmic dance. Stars are not just celestial bodies. They are the storytellers of the universe, carrying the wisdom of creation and destruction in their glow. Their light, their energy, and their legacy echo across the vastness of time, shaping everything we know and continuing their silent journey through the cosmos.